Hello folks, and welcome to the channel P20. In this video, I'm going to be talking about the dev folder and the udev daemon in Linux. These are two important concepts that you need to understand if you want to work with hardware devices in Linux. The dev folder is a special directory in the Linux file system that contains files that represent hardware devices. These files are called device nodes, and they allow the kernel to interact with the hardware devices. The udev daemon is a system service that manages the device nodes in the dev directory. It is responsible for creating and removing device nodes, as well as assigning permissions to them. In this video, I'll explain what the dev directory and the udev daemon are, and how they work. I'll also compare udev with the Windows Device Manager, so that you can see the similarities and differences between the two. So, if you're interested in learning more about hardware devices in Linux, then this video is for you. Stick around, and I'll show you everything you need to know. So, let's dive straight into the content. The dev folder contains device files that represent the various hardware devices attached to the system. It's important to note that these files are not drivers. These files act as a bridge between the kernel and the physical or virtual devices, enabling communication and data transfer between them. Files in the dev folder can be categorized into two types, based on their purpose and the devices they represent. Physical device files. These files represent physical devices connected to the system. For example, SDA file inside the dev folder represents the hard drive, TTYS0 represents a serial port. Files inside the SND folder represent sound devices. Virtual device files. These files represent the virtual devices. For example, TTY file represents the active terminal. Null file represents a null device. Null devices in Linux are special files that are used for discarding data written to them and providing empty data when read from. Mostly, administrators use it for dumping useless data, so that it doesn't hog system memory and processing power. They even delete useless files by moving them directly to null. Now, let's see how these device files are created. The files in dev folder are not permanent storage files, but rather dynamic entries, representing the devices currently available in the system. These files are created every time you start the system, or when new devices are detected or configured. They are created by the udev daemon, based on the rules specified by the rules.d file, in the etc folder. Now, what exactly even is a daemon? Well, a daemon is a process that operates silently in the background. Daemons typically start during system boot and continue to run until the system shuts down. They operate silently, performing their duties without requiring direct user intervention. Here, the udev daemon dynamically creates these files based on the rules in rules.d. It's fair to say that udev in Linux is equivalent to the device manager in Windows. The device manager is an important component of any operating system, handling the detection, configuration, and management of hardware like storage drives, printers and peripherals. On Linux, udev operates automatically in the background, without user intervention. When you plug in a new USB drive, or connect a Bluetooth speaker, udev dynamically detects it, and loads the necessary drivers. This hot plugging allows you to seamlessly add and remove devices on the fly without restarting your computer. On Windows, the device manager is more beginner-friendly with a graphical interface. The Windows Device Manager provides an admin utility that lets you manually view, configure, and troubleshoot devices on your system. However, it does not have native hot plugging support. You typically need to reboot for device changes to fully take effect. The difference comes down to the philosophy. Linux favors a lightweight, but highly customizable approach, putting power in the hands of the user through text configuration files. This allows advanced modifications, though it can be a bit complex for new users. Microsoft Windows prioritizes convenience and automation. Windows Device Manager simplifies tasks through its point-and-click interface. But this comes at the cost of less low-level control and tweaking. In summary, the Windows Device Manager is beginner-friendly, offering a user-friendly interface. In contrast, Linux enthusiasts appreciate udev for its flexibility and seamless device connectivity, which simplifies the process of managing hardware. Both achieve the core goal of managing devices, just with different approaches. In the next video, I'll show you how to install a graphical device manager in your Linux system. This will allow you to view and manage your hardware devices in a graphical interface, similar to the Windows Device Manager. If you find this video helpful, please leave a like and subscribe to the channel. Thanks for watching. I'll see you in the next video.